who are active on Twitter, please feel free to use our official hashtag, which is hashtag CTIA handle @Here's Wireless. I'd also like to thank our sponsors. You're on.
It should be on, but we don't want to pronounce it right.
Sigfox and Qualcomm. For more information about our speakers, please check the programs on the table. Also, please fill out the information forms on your table. Me, that's me. Okay, there we go. Thank you. Okay, I'll talk a little more loudly. Yeah, thanks for letting me know. If you guys can't hear, please continue to let me know. Please fill out the feedback forms on your table. We're also holding events at CES and the Congress, so keep an eye out for those, please. We have a 5G event tomorrow morning, another breakfast hosted by my colleague Mike Dana. If you want to hear about 5G from executives from Verizon, AT&T, and other top players, please register for our breakfast. I've been asked to pass on. You can register for that today, make everybody's lives a little bit easier tomorrow morning. I've also asked to pass on, that's not included in the typical registration for CTIA. So, we'll plan to do about 20 minutes at the end of our discussion for questions from the audience. We'll make sure we leave plenty of time for you to get to this morning's keynote speakers at the show. With that, I'd like to ask everybody to please turn off your cell phones and other electronic devices, and let's jump in. Thanks to all of you guys participating. Thank you. Very excited about it. We've got a lot of different perspectives up here, a lot of knowledge. So with that, I'd like to ask our speakers to introduce themselves, briefly explain what their role is, and roles are in relation to the IoT. And perhaps if you've got a particular technology, very briefly, we can discuss that a little bit. You want to tell us a little bit about the technology you would currently are backing. But again, I'd like to keep this brief. We have 6 of you. We have a lot of ground to cover. So with that,
well, thanks for joining. 7 a.m. on day 1 of the conference. I'm really impressed that I'm speaking to you, especially in Las Vegas. My name is Monty Ingram, and I'm the Vice President of our Smart Communities and the news organization within Verizon. And our role really is to be, my role especially is to be able to focus on how we can enable our technologies to drive improvements within communities around the world. And this could include cities and municipalities, universities, sports and entertainment facilities. And in addition to that, I'm also responsible for our things-based platform, which enables the rest of the IoT solutions, as well as things such as our telematics solutions and our small medium business. So we are really looking at a tremendous amount of different types of technologies, especially leveraging our 4G LTE network to be the basis for most of this. But we recently have also announced our CAT M and CAT 1 device, and I think that that's going to actually be something that we will talk about while we're here, but we see that as being a real strong enabler. And also looking at future technologies, especially being very aggressive with 5G, to really look at the diversity that's needed to drive this industry. Thank you.
Hi, I'm Cameron Corsi. I'm with AT&T's Internet of Things Solutions Group, and I lead the product development organization. I guess that means that we put the Internet of Things for AT&T, and we kind of make it work from the technology to the launch of the technology with our different customers. So we've been in this for a while now, supporting it through different technologies. We're really multi-network. We believe that the IoT space can be one where a lot of different technologies can be used on the wireless side. There's billions of possible connections out there. So we embrace the ones that we already have a lot going on in all the cellular domains. We've done that for a while now. And moving into the licensed low power wide area world, which we'll talk about today, and satellite and other areas, Wi-Fi. So we embrace a lot of them. Thank you, Joe.
John Morton, CEO of Engineer, and we are the only technology that's been built from the ground up specifically for machines that didn't take a spot along the way doing anything else. And our technology is called RPMA. If you look at the machines that are deployed in the world today, 86% of the machines already deployed could run on an RPMA network. We have running on 5 continents as we speak. We have 63 countries in process where we are going to be building networks either ourselves or through licensees. So we will have a significant large global footprint where you'll be able to use one radio, one device, anywhere in the world, and phenomenal technology and support ecosystem.
Good morning, my name is Craig Miller. I'm the Vice President of Marketing for Sigfox Communications. We're an LTE chip maker, and what's sort of unique about us is we're pretty uniquely focused on optimizing LTE chips for the Internet of Things. We were the first chip company to launch and commercialize LTE Category 1 for IoT applications. We were first to launch Category M1 back in the Annual Congress, and we're demonstrating it live this week in our space here at CTIA. And I think we view our role as sort of reducing the barriers for device makers and end-to-end implementers, barriers in cost, size, power, simplicity that maybe have existed in the past or are perceived to exist in the industry today. And so we're doing everything we can to pull those barriers down and make it easier for developers and implementers to make great IoT applications that run on LTE networks, folks like Verizon and AT&T.
My name is Art Miller. I'm part of our IoT business unit within Qualcomm, specifically on the chipset side. I handle our smart cities and industrial Internet of Things space. We are also focused on LTE. We also have some technology that's been focused on machine-to-machine over time. We have made 2 stops, done pretty well in the smartphone space. But we are focused on end-to-end. We've been heavy drivers and standards for 3G, 4G, due to drive 5G. We believe the evolution path is going to be necessary to truly connect all of these things worldwide with standards-based solutions. We're very excited about M1. We're partnering with a few folks on the stage to drive M1 products into their networks. We're very proud of that, and we're very excited about it. We think there's a lot of possibility. One thing that we also have is we're uniquely positioned where we have connectivity across the board: Bluetooth, Wi-Fi, PLC, anything that needs to be connected, we can connect. And so we have a tendency to look at things more from a system approach of all things at the edge. Also, we believe that edge compute becomes a bigger deal. We're uniquely positioned for that based on all the things we've done in smartphones.
I'm Michael Orr. I am with Sigfox. I'm the Vice President of Sales and Partners for Sigfox in North America. We are a global, low-power, wide-area network provider. We're building a network globally. We have operations in 24 countries with a target of 60 countries by the end of next year. We too were designed from the ground up to be a strictly IoT network, very small amounts of data, very low power, very low cost. That's our niche. We are about enabling the masses for IoT. All those devices that have not had an economical or power efficient way to get on the internet, that's what we enable. That's why we're here.
Thank you all very much. When we first started talking to this panel about questions when the speakers were talking to me, Craig suggested we just jump right into the title of this roundtable, which next generation networks are going to live in, which are going to die. And as compelling as I found that, and I like that a lot, we're going to lay the foundation first before we jump right in there. So with that in mind, Art, I'd like to ask you, where do you think we are in the evolution of networks for IoT use? What kinds of networks and technologies are being used to serve the IoT right now, from your perspective?
Okay, well, I think IoT exists today. For people to say IoT doesn't exist, I think is a bit of a misnomer. It's been there for a while. It's previously called machine-to-machine. IoT is, I guess, a sexier name at this point, and people are excited about it. That's why we all have it on our business card now. So it exists. The problem is there are some barriers to entry, which some of these folks have already talked about. But as things progress, I think just recently, with 3GPP focusing on their narrowband solutions, specifically M1 and NB1, there's now the reception of barriers being done, opportunity for devices to be more cost optimized and longer life and feel. And then moving into 5G, we certainly see the narrowband technologies that have been introduced to 3GPP this year being commercialized early next year on the carriers are kind of this foundational base for 5G. So things will continue to evolve in parallel. It'll act as a foundational base for 5G. So we think we and 3GPP-based technology are uniquely positioned for longevity. But we're at the beginning. We're certainly, the sky's the limit right now. But there's a good future here.
Very good. Anybody have anything to add to that? Okay, very good. Do the networks and technologies that are being put to use right now, do they vary based on different vertical markets and use cases? And if so, how? Michael, you want to tackle that first?
Well, certainly the networks do vary a bit based on use case and application. I mean, you may want a small cell to cover a specific area in a factory or something like that. So you can have the use case drive the deployment of the technology that's out there today. By and large, Sigfox's network will be homogeneous. We're not going to change the network for the different applications. We may need to tune it up here and there as we go. We need to tweak it a little bit. But by and large, it will be the same network everywhere we deploy.
You know, if you look at what's happened in the technologies out there, the carriers have done an extraordinary job with LTE. LTE has delivered on all the promises that we all expected it to when I was sitting in these chairs, and done an extraordinary job. But you know, LTE is built primarily as a human interface technology, and it's been extraordinary. And now we're, you know, with the discussions coming with whether it's Cat 1, Cat 0, Cat M, LTE, whatever, NB-IoT, whatever it's going to settle on in the end, these are ways to try to maximize LTE more for the machine network instead of having a network for machines. And that's what RPMA is built for. It's interesting because on my board I have the former CEO of Verizon, former CTO of Verizon, and the co-founder of Qualcomm, who all say that LTE is absolutely everything we want for people, but RPMA is for machines. So I think technology is going to come out here with the expansion of what Sigfox is doing, what Ingenu is doing, and others, and it will fragment to a degree based upon the needs. We can't do high-speed data or video or voice. These guys can live that all day long, but we can provide a technology that gives you an extraordinary opportunity to really have coverage everywhere you need it and have the machines prioritized, not the people, but the machines, so you have the coverage every day, everywhere you need it.
So maybe if I can just add to that first real quick. I think that use cases for IoT in general are incredibly diverse. And as a result of that, it's going to take a diversity of different types of technologies to really solve the problem. I don't really believe that there will be one network or one technology solution that is going to be the basis for every type of use case that are out there. I would say 90% of the use cases we haven't even thought of yet on the planet, if not more. Great example of, say, something in my industry around smart communities, something as simple as parking. If you think about maybe a parking sensor that might sit in the cement itself, or something that might walk. Maybe that would require one type of networking device to be able to do that. It may also be able to have a parking solution by the cameras that are going to be sitting on top of light poles and the video feeds that can actually detect whether or not a parking spot is there or not. And honestly, I believe in the end it's probably going to be a triangulation of several different types of ones, because no one is going to be able to provide 100% of the right type of accuracy in that data to provide the level of solutions that we're going to expect to see in the future. So I do agree with everything you're saying, but I just think it's going to be a combination of so many different technologies, the ones that we're talking about today and ones that will continue to develop in the future.
I would just add, Colin, I think from our perspective, the beauty of LTE-based technologies is these networks exist. They've spent billions on spectrum and coverage to build these networks that cover most of the United States already. You don't have to wait for a new network technology to be deployed. You've got a range of technology options, from the high-speed stuff for the media and video that you're talking about to the very, very low data, payloads of a parking meter sensor that can all be served on the same RAN using LTE-based technology, going from Cat 6, Cat 4, Cat 1, M1, narrowband, all based on LTE technology. That's the beauty of the 3GPP standard.
And if all of those work so well, you wouldn't have NB-IoT, Cat 1, Cat 0, Cat M, and all the other things, because LTE would be the answer. LTE is the answer for some things, But the vast majority of machines don't need LTE, and it doesn't give them what they need.
Those are all basic technologies.
I realize that, but they're based upon an LTE backbone, and you've got all these different modules, all these different radios. You're complicating things that's already too complicated when it needs to be simplified.
So I take some exception to what John's saying. I guess
I'm
that's
surprised,
surprising. You know, we're not after the internet of a few things. A few things is what RPMA can do, right? We're after the internet of all things. And to do that, that does take multiple technologies. That takes things that can go very, very fast. Big bandwidth, right? To do firmware updates to things or set up Wi-Fi hotspots in connected cars. It takes very, very low bandwidth things that can remotely start cars weeks after somebody has left them somewhere, right? With very good extended coverage, with very good power saving mode. All of these are things actually that the cellular technologies can do going forward with the licensed low power wide area, LTE M and narrowband IoT.
Michael, anything you want to add to that?
Well, certainly. I certainly see that, to Delani's point earlier, IoT is really, really big. It's bigger than anything we've ever done before. Everything we've done so far has been enabling people with devices. Well, we succeeded. I think all of us in the mobility space, we won, right? Everybody's got a device already. 7 billion people on the planet, 8 billion subscriptions, everybody's got one. How many machines are there in the world? I don't know, do you know? There'll be hundreds of billions. I think going forward, every device that's made over the next 5 to 10 years will have connectivity in it. Every single one. Silicon's cheap, cloud is cheap, why not just stick it in, right? It's gonna be there. So once it's there, then what do you do with it? Nobody knows how long this is gonna take, nobody how long it's gonna take to get that big curve to go up. But I do know that no one technology sitting here is gonna fit all those things. It's not gonna happen. Is there room for all of us? Yeah, I think there's probably room for all of us for a while. Are some of them gonna fall by the wayside? Yeah, probably yes, they always do. But it's a really, really big market. Way bigger than anything we've seen before, right? So there's gonna be room for LTE, some people need video, some people need real-time stuff. We're targeting the very low end of the market, right? Low cost, low data rate, very low. Is there room for that? Yep, there is, absolutely, right? So it's a really big market. It's a mistake to think that any one of them is going to take 90%. It's not going to work like that. That's how I see it.
You're obviously right that there are a lot of technologies. Am I still on here? Can you guys hear me?
Yeah.
Okay. There are a lot of technologies already being deployed, many more being developed. And the title of the panel again is which will live and which will die. Are we seeing any signs of attrition in any of these technologies? Are we seeing any of them fall by the wayside?
I don't see it yet. It's too early, right? I mean, we're just starting on the big IoT deployment, right? It's just starting to happen. It's too early for things to fall by the wayside, unless somebody made some kind of catastrophic mistake. I mean, there are some low power WAN technologies that have been proposed and have fallen by the wayside already, but not anything mass market. I think it's too early for that to have happened yet.
Very good. Thank you. Craig, back to you. Where are we in the evolution of LTE and NB-IoT commercial deployments?
Yeah, so I think what we've seen is, and this has been actually fairly remarkable for 3GPP technology. If you followed it over the years, they're not exactly known for their pace. But I think what's been clear, and we can thank guys like John and the friends at Sigfox for actually kind of lighting a fire under 3GPP and the operators that support it to move fast on IoT-specific standards that leverage the strengths of LTE technology and the deployed networks. What you're seeing now, and Release 13 specifically is what I'm referring to, which locked down earlier this year. Two new narrowband technologies were defined in that standard, Category M1 and Category NB1, or what's narrowband IoT. Two different levels of performance, two different use case kind of profiles, both of them defined in Release 13. What you see now is, I think, and we're an example of this, CAT M1 silicon up and running now, working with network vendors and operators to start getting ready for trials and deployments by the end of the year. Narrowband IoT is close behind, I think, and in different parts of the world, different operators have different priorities. They may prioritize narrowband over M1. Eventually, they're all going to deploy both because they're both needed. And that's how we see it. I think you'll see the first commercial networks on M1 around the end of the year. I think both of our mobile operators on the panel here have made some recent announcements with regard to that. And narrowband IoT will be shortly thereafter.
Anyone else? Thank you. We've already touched on this a bit, but to drill down, what should we expect to see as dedicated IoT networks gain traction alongside traditional wireless technologies and networks? Will the two segments complement each other, or will they compete with each other? And part of that question includes like the business model. What kind of partnerships are we going to see? And are there different business models between the two, between those two types of businesses?
The answer to all the above is yes. Frenemies compete, get along. I mean, we have licensees around the world that are going to be competing against the incumbents. We have licensees around the world that are the incumbents. They're going to be building RPMA networks within their footprint. So I see there's so many different ways to compete and to cooperate. There's no way we're going to connect 1 trillion machines with one technology. I mean, we're already here listening to 3, LTE, M1, NB-IoT. So there's 3 just on the cellular side, right? And that doesn't even count the sunsetting of networks and all the other issues that come with it. But the bottom line is that there's room, as everybody has said, for all of us to be successful if we create the right environment, the right business model, and have the technology to back it up.
I would agree with that completely. And one of the things I feel as well is, it's actually one of my favorite things about being a part of this particular industry is, even though we're all competing in many ways, we really are partnering because we want to see the industry successful. The pie is big enough for everybody, and we have no idea how big that pie is going to grow if we're all successful. And I think the industry is looking to us as leaders to ensure that we are working together. We need to ensure that we are building the same standards and that we are operating with similar thought patterns and architectures and driving business models that are not confusing to the market, to your point on that. I think that it really requires us to challenge one another, which we do all the time, but also to work together. It's my favorite part about this industry, actually.
Thank you. Spectrum. I'm just going to throw this out there because I would imagine you could all speak to this. But what role is Spectrum playing as the IoT begins to get legs, and what role will Spectrum play on either side of this, the cellular networks and the dedicated IoT networks, as these things evolve over the next few years? Anyone?
I think it plays a big role. I mean, you need Spectrum to do anything wirelessly, right? So you have to determine then, is it licensed spectrum, is it unlicensed spectrum, right? Today, IoT is in both, and it will probably stay in both, right? There are use cases where you need to use licensed spectrum for certain things, and you have it around the world, and you're able to do roaming globally with standards like the 3GPP standards. There are unlicensed ones that probably take a little bit more to make sure that it works everywhere in the world, right? But they're all going to exist in the spectrum that we have to work with. We obviously need to make sure that everybody is using it for the right purposes and making use of it in an efficient manner. So yeah.
So in our case, for Sigfox, we're targeting the lowest cost, lowest power consumption for low data rate applications. It's very important for us to be in unlicensed spectrum because we're trying to get the cost as low as possible. But that does come with a burden too. I mean, that spectrum is wide open, but everybody's in there, so it's noisy. We have to be able to work in that kind of environment. We don't have as much control over it. Whereas in the licensed spectrum, you have more control over it. It's not as noisy, et cetera. So our trade-offs for both. But we're targeting the lowest cost applications. We need to be in the unlicensed band. It's important.
And I think that's key. You mentioned it's going to be how much control do you need. Many use cases that require quality of service or certain secure elements or control of the devices. I think that's going to fall clearly into the licensed spectrum.
I disagree. I mean, we've got networks running all over the world. I've got networks running nuclear power plants. If they aren't secure, we have a big problem. And so you can be an unlicensed spectrum, and if you manage it properly, and you're a good neighbor, and you can do very well in that spectrum. We have networks running in Los Angeles, Seoul, Tokyo, sort of like congested environments. And they're running very, very well. And the advantage that we have, because we picked 2.4, is one radio will work in every country on the planet, because it's the only spectrum that's ubiquitous in every country on the planet. And we're about, again, making it easier and simplifying this process. And for anybody that needs a global, true global solution, whether it's shipping or whatever it happens to be, one radio is a pretty appealing opportunity for them.
Hey, where's that nuclear plant at?
Yeah.
Because I want to stay away from there.
Thanks, Cameron, I appreciate that. It's in your backyard.
One thing that I would say will be interesting over the next, say, 5 years, if the market's gonna get as big as we all hope and expect it will, is the existing allocation of spectrum, especially in the licensed spectrum. Is it adequate? Is there enough of it? Do we need to go to 600 megahertz, which is under auction right now in the U.S., which gives the properties, the propagation and coverage and properties of the low band spectrum is really good for a lot of IoT applications, getting wide coverage, indoor penetration, underground, those kinds of use cases. I think it'll be interesting to see what the operators in particular decide where they're going to focus the IoT applications, which means.
I think it's really important for us to also just keep in mind what problem we're trying to solve. And each one of those are going to require a different level of security and protection amongst it. If you're, again, working with a community, which is my world, and you're talking to a government leader and they're not want to do something, and all of a sudden, something goes haywire with that, with some of their primary assets, and things that can get hurt, or their data is compromised. So I think in areas like that, we probably spend a lot more time on focusing on the security of the data, security of the information, ensuring that things are operating at a level of efficiency that we're used to doing every single day. And that takes a lot. That might be different maybe in other technologies or other use cases that may not necessarily require that level of security and protection. So again, I do think that there will be different technologies to support different areas, but any place that does require a certain level of protection and security, I think we need to ensure that we've got the right technologies to support.
Let's talk about costs for a few minutes. What are traditional 3GPP mobile operators doing to reduce the data plan costs to enable new IoT business cases to succeed? And how does pricing compare to those offered by non-3GPP LPWA networks? I'm guessing a couple of you have opinions on this. Craig, let's start.
Well, I'm not an operator, so I'm not going to put pricing, data plan pricing numbers out there. But I do know that we talk to operators around the world, and there is great awareness of the need for a different approach to these use cases than the traditional, mobile phone plans and tablet plans that that exist out there. So there's great awareness of it. There is active work underway at a lot of operators to optimize the actual OpEx, if you will, of running IoT services on their network compared to a mobile phone. So there are things that you can do in how you administer the network, the back office, the core network, what you use and how much it costs to operate that network. So that enables them to stay profitable while reducing, the cost of data plans. So I think that's important. There's a lot of focus on the cost of modules and hardware. Guys, that's going to get taken care of, right? Cost follows volume, and complexity reduces cost, and all of that's happening in all of our technologies. So the cost of the module, the chip, et cetera, Moore's law and physics are going to drive that where it needs to go. The cost of the data plans is up to the operators, but I know that they're working on it. I think you should ask Cameron and Lonnie.
The thing that if you work in the IoT space, the enterprise world, you would probably understand is that the majority of the data plans that we're talking about are not the same as what you as a customer would use for your smartphone or your tablet. These are bulk data plans
that get sold to enterprise customers at very, very low rates that we don't talk about. And this is, so there's not as much of a barrier